Hello. In this example, we're going to solve the following triangle. So the question that naturally comes up is, what does that mean? Solve the triangle means find all side lengths and angles. And the easiest way to organize yourself when you do a question like this is to simply make a table like this. And this helps us identify what information we have to start with and what information we need to find. So what I do is I set up this table and I say A, B, C to represent the side lengths, and angle A, angle B, angle C. So now to start with, let's pull out what we know. So we follow the typical triangle naming convention. So if this is angle A, this is side A. If this is angle B, this is side B. And if this is angle C, this is side C. And what we can see is already given to us is that A is 15 units, and we don't specify, so it could be any units. B is 8 units. We don't know what C is. We don't know what angle A is. We don't know what angle B is. But we do know angle C is 90 degrees. And again, don't forget that degree symbol. If you leave that degree symbol out, you are implying that it is a measurement called a radian. And I'll perhaps throw up a video about radians for you to take a look at, though we don't cover it this year. Okay, so the first thing I'm going to do is solve for C. So 1. We're going to solve for C. Now, in this case, I have two sides of the right angle triangle, so I can use Pythagorean's theorem. So C squared is equal to 15 squared plus 8 squared. 15 squared is 225. 8 squared is 64. And that gives me 289. So therefore, C is equal to the square root of 289. Now, you might recall from earlier on this year that we said that when you actually physically take the square root, you have to account for the plus or minus case. However, in this case, since we're talking about a length, we can assume that only the positive value is used. So we simply just say this is the square root of 289, which conveniently is 17. So side length C is 17, and I do my mental check here. C is the hypotenuse, so therefore it has to be the longest side. And this is another Pythagorean triplet for those of you who are keeping track. 2. Now I want to solve for one of the angles. And I can solve for either A or B. Let's solve for A first. So we're going to solve for A. So again, a lot of students can do this by inspection, but initially sometimes it's useful to be able to draw out this chart. And what we're going to do is, well, we're going to check mark off what we need and what we have. So we need to solve an angle, so we need to have either sine, cos, or tan. So I'm going to check mark all three of those. It turns out now that I have all three sides of the triangle, so I can actually use any of these primary trig ratios. However, a strategy I recommend is, since you've been given the opposite and the adjacent with reference to A, so we have the opposite and the adjacent, I would recommend using tangent, because if by chance you made a mistake calculating C, that mistake won't carry into this calculation. So we know that, well, let's change our color here, go back to blue. We know that tan of A is equal to the opposite over the adjacent. So tan of A is equal to the opposite, which is 15, divided by the adjacent, which is 8. And like we said, to get A by itself, we apply the tan inverse to both sides. So we end up with A, because the tan inverse of tan A is simply A, is equal to the tan inverse of 15 over 8. And now I can plug this in my calculator. So we have 15 divided by 8, and I take the tan inverse of that, and I get approximately 61.928, and don't forget this, degrees. So angle A is approximately 61.928 degrees. So now I want to find angle B. And there's a couple ways I can do this. Find angle B. Probably the easiest way is to say, well, if I know there's 180 degrees in a triangle, that means that 61.928 degrees plus 90 degrees plus angle B is equal to 180 degrees. And so I rearrange that and I get angle B is equal to 180 degrees minus 61.928 degrees minus 90 degrees. And if I calculate that, what I get is angle B is equal to 28.072 degrees. So we have 28.072 degrees. And at this point, I'm going to do a little check because I've solved everything now. So let's see. C is the largest side and is across from the largest angle. A is the middle length. Sorry, side A is the middle length and it's across from the middle angle. And side B is the shortest length and is across from the shortest angle. And therefore, everything checks out. The reason why this check is so useful here is often what students will do is they'll accidentally get their tangent ratio reversed and solve for the other angle. And by doing this check at the end, you'll always catch that mistake. One last point here, just to make sure everyone sees this, is that alternately, to find angle B, I could use any of the trig ratios. So let's use sine. So I'm going to say sine of B is equal to the opposite. So if this is B, the opposite will be 8 over the hypotenuse. So if the hypotenuse is C, so that's 17. So B is equal to sine inverse of 8 over 17. And now I get my calculator out and work this out. So I'm going to say sine inverse of 8 divided by 17. And be sure you can type this in your calculator. And sure enough, I get 28.072 degrees. So I'm right. So the key thing is there's lots of ways to do all of these problems. I hope this video helped. Good luck.